In this video, we're going to learn how to determine the future value of a lump sum of money. So the first formula I want to bring your attention to is a simple interest formula. If you want to calculate interest, you need to start with a principal amount, which is usually the present value, like a starting amount. Multiply it by the rate you want to multiply by, and then however many years you want to do that for. And that will calculate how much interest you'll accrue over a set period of time. So let's put this into effect. Let's say a credit union pays interest of 8% per annum, which is every year, compounded quarterly on a certain savings plan. Quarterly means we'll do it 4 times within 1 year. If $1,000 is deposited in such a plan and the interest is left to accumulate, how much is in the account after 1 year? So let's use this formula. Well, it's going to be quarterly, so we'll look at the first quarter. I'll call this I1 is equal to the principal amount, which will be $1,000, the present value of it, times the rates, which let me write this down, so $1,000 for the principal. The rate is 8%, but we'll use 0.08 for our formula. And the amount of time that's passing in 1 quarter of a year will be 1/4 of a year. So when I plug everything in, I'll get 1,000 times 0.08 times 1/4, which is the same as 1,000 times 0.02, which will give me, plugging this in, 1,000 times 0.02 is $20. So my interest is $20. Now when I do my next interest calculation for the second quarter, instead of using $1,000, I'm going to use 1,000 plus $20 as my present value into the second quarter. But I'll still have the same rates over the same time. So that will be $1,020 times 1/4 of 0.08, which is 0.02. And that gives me an interest of $20.40, which I'll add on to that principal to do my third quarter. And I'm going to keep this up until I'll do all 4 quarters, and then I'll see how much money is in the account after 1 year has passed. So now I'll take my $1,020 and I'll add my new interest amount of $20.40, which is $1,040.40, which I can just put 0.4 for. I'll put 0.40. Then I'll do times 0.08 and 1/4 of a year again, the same time period. So I'll put $1,040.40 times 0.02, that's 1/4 of 0.08. That gives me $20.81 when rounded. Then I'll calculate for my fourth quarter. I'll have to add this onto my principal. So $1,040.40 plus $20.81. This gives me $1,061.21 times the rate, 0.08, times 1/4 of a year. So $1,061.21 times 0.02. And I end up with the last interest I gain is $21.22, which when added on to get my final total will be 1,061 plus 0.21 plus 21.22, a final amount of $1,082.43. So after 1 year, this is how much money I made. So you notice how if I just took 8% of 1,000 that would have just been $80, but I earned a little more than $80 because I did it quarterly. I compounded more recently than just one lump sum for the whole year. Now, this brings us back to a compounded interest formula, which the way you calculate this is you're always multiplying by that 0.2 every year and adding it on. We can do this with an exponential function by taking your principal and multiplying it by 1, which is equal to p if you just multiplied it in. So your principal amount. So 100% plus your rates divided by the number of compoundings in 1 year. So this is the number of compoundings. So you divide the rate over that. And then how many times should you multiply by this number, which was 0.02, but we're doing 1.02, just so it preserves the original principal amount. How many times should you do this? Well, it'll be the number of compoundings times the number of years passed. So if you did it quarterly, it'd be 4 times every year. Now, if we use this formula on the previous problem, instead of having to go through this process 4 times to get the answer, using this formula, A usually represents a future value. You have your principal of 1,000 times 1 plus your rates, 0.08 divided by 4, which was how many compoundings we did, 4 of them in 1 year, raised to the 4 times 1 power, because we're doing it for 1 year. And if I plug this in, my A value will be, so I have 1,000 times 1 plus 0.08 divided by 4, all raised to the 4th power. I'll get $1,082.43. So it's a quicker way to accomplish the same goal instead of having to reiterate on it over and over again. So let's put this into practice. Let's say we want to find the amount that results from each investment, which is $1,000 invested at 10% for 5 years, compounded annually, semi-annually, quarterly, monthly, every single day, daily, and then continuously. And I'll get into that aspect in just a moment. But annually means that only once a year. So the number of compoundings would be 1. So if I use that in the formula, I'll get that my future value will be $1,000, my principal, times 1 plus the rates, which was 10%, so 0.1, over 1, because there's only 1 compounding, to the 1 times 5 years. So only 1 time a year. So doing this, my future value will be 1,000 times 1 plus 0.1 divided by 1, raised to the 1 times 5 power, which is just 5, giving me $1,610.51. Now let's do it semi-annually, which means twice a year. So n will equal 2. So halfway through the year, I'll compound some interest, and then I'll do it again at the end of that year, which means I'm going to do it 2 times every year for 5 years, so that power I'm going to raise to is 10. It's like I would do this 10 times to calculate it. So A will equal 1,000 times 1 plus your rate, 0.1, divided by 2, because we're splitting up the rate over the year, raised to the 2 times 5 power, 2 times every year for 5 years, which will give me approximately, let's calculate this, 1,000 times 1 plus 0.1 divided by 2, raised to the 2 times 5 power, which is 10. That gives me $1,628.81. and 89 cents. So already you made more money by doing more compoundings within the period. That makes sense because you're taking that previous value and doing it again as it increases, while annually it would only increase every year. Semi-annually increases every half year. So see how much more money you make as we divide up our year. So let's do it quarterly, which means every 4 times a year. This is what I did earlier. That's what that 1/4 was there. So I have A will equal 1,000 times 1 plus 0.1 divided by 4 raised to the 4 times 5 power. So 1,000 times 1 plus 0.1 divided by 4 raised to the 4 times 5, which is 20th power. And I get $1,638.62, which is already $10 more than before. So it's getting more and more every time I do this. So let's do it monthly, which means 12 times a year. So n will equal 12 for my formula. I'll replace n with 12. So A will equal 1,000 times 1 plus 0.1 over 12 raised to the 12 times 5 power. So 1,000 times 1 plus 0.1 divided by 12, all raised to the 12 times 5 power, which is 60. And this will be approximately $1,645.31. But I can keep doing this. Let's do it daily, which means 365 times in a year. Unless it's a leap year, then 366. But we'll go with simply 365. So my future value will be 1,000 times 1 plus 0.1 divided over 365 days. And raise that to the 365 times 5 power. And we'll figure out how much this is. How much money would be in the account if it was every single day a compounded interest. So 1,000 times 1 plus 0.1 divided by 365 raised to the 365 times 5 power. That will give me $1,648.61. So you'll see here it went up by a little more each time, every time I divided up the year. So continuously would mean that n would be essentially infinity. Like every moment of every day, you're constantly compounding. So if I approach this expression 1 plus 1 over n to the n as n goes to 1,000, we talked about in a previous lesson that this just equals e, which is approximately 2.71828. But that's just the letter e. And if we look at that entire formula, and just take away the principal and the time, look at 1 plus r over n to the n, that expression is equal to, if you just replace the 1 with an r, e to the r power. So essentially, if you put 1 in for r, you would just get e. So knowing this, a formula for continuously compounding will be a is equal to p, the principal, and to replace this inner part, 1 plus r over n to the n, replace that with e to the r, and then also raise it to the t power. So you get p times e to the rt. So this is continuous. So this is like a maximum cap of compounding money. So you can't compound it any more than this. So this gives you kind of a cap of where this eventually will end. So if I do that, I'll have a is equal to 1,000 times e to the rate, which is 0.1, times 5 power. So give me approximately 1,000 times e to the 0.1 times 5 power, $1,648.72. So not much more than daily. So it turns out that daily is pretty close to a continuous compounding. You only make a few more cents by doing it an infinite number of times. So again, continuous is ends like approaching infinity there. And that is how you determine the future value of a lump sum of money.